Okay, hello again and welcome to our webinar. My name is Petr Hajek. I am information management professional. I work for Profinit, and today we will talk about data transparency, what it is and how to achieve it by data landscape mapping. Before we start, I would like to tell you that the webinar is recorded, so if you say something or if you show yourself on video, it will be recorded on the record and will be then made, public for other users of the webinar who will join offline. Okay, let's start then. And I guess that there is no company or business or enterprise today which would not be flooded with lots of data. And yes, we see data everywhere. It's very complex system. We typically do not understand much of all the data in our companies and so on. And I will borrow a term from physics. The term about systems, the term is entropy. Entropy is quality of a system, which says how complex and how unorganized it is. And I like better definition of entropy. For me, the better definition of entropy is that entropy is how much we do not understand the whole system in its complexity, in its maybe chaotic, behavior and so on. So if we talk about data transparency, for me, it is how to decrease the entropy, how to better understand the data in our company, the whole, biosphere of data in the whole organization. And if we talk about, if we try to do something with data in our companies, we take different actions, but we typically say, or we consider data as a problem. We say we have problems with data, we have to resolve it, and we do a lot of different activities, actions. We run corporate programs to establish data management or data governance programs. We try to create new departments for data management, data quality management, and so on. We spend a lot of money for expensive tools to manage data, manage metadata. We create a lot of business warehouses. We do business catalogs and so on. Or we try to hire some supermen or superwomen who we believe that will help us somehow miraculously to resolve all the troubles, and we call them data governance officers. Or we seek for data stewards, those experts who have been with the company for maybe 20 years and who we believe that they know everything and they will help us even with the data and so on. But before we move on, before we start talking about what is the better approach rather than these expensive things, I would like to ask you, you work for different companies, and I would like to know how many people come from companies that you believe that you have established well, working, functioning data governance or data management inside the company, and you think that the steps that you have taken are the right ones, and you will only continue with them. If I may ask you just to raise your hands again. I see. Actually, few of the listeners, raised their hands. And maybe I would like to know if there are really data governance officers, these formal roles within the organizational structure that are formally responsible for data. Maybe even you who listen and watch this webinar, you are in this role of data governance officers, or at least somebody of your peers maybe who is in this role. Can you again please raise your hand and I would like to know how many such people we have in the room. Okay. Actually, not so many. I think if I'm Yeah, I see. I think one or two, only one or two people. So I think that in this case we can quite easily agree that the steps that are usually taken towards resolution of problems with data are at least not satisfactory, or we may say that they are too costly, they consume too much time, and they typically bring unsatisfactory results, or at least the expectations maybe were higher at the beginning. So we may say that the journey towards what we call decrease of entropy in our data, that the journey is a story with very often bad ending. Yeah, and the question is how to make it a story with good ending. And I think I know how to make it, and I will again borrow a solution from the outside. And when I was a kid, I loved books by Arthur Ransom. It was a writer who wrote, adventurous books about swallows and Amazons. And these were books like, Peter Duck, Winter Holiday, and We Didn't Mean to Go to Sea, and a lot of books like this. And there was one feature in all these books. And before I will tell you what the feature was, I think we will need to make one important step. And the step is to stop thinking about data as a problem, as something that needs to be resolved, something which represents a bucket of troubles. Rather, I would like to start thinking of data about a treasure, yeah? Because there is a lot of value in the data, and it's very similar to a treasure. And generally, where to find a treasure? Very easy answer. We may find a treasure on a treasury island. And how to find it on such island? It's easy. You need to have a map. So the feature of all these books was that there was always a map at the beginning of each book. So the reader could have perfectly understood what happens in the story and where it happens. So the story became more readable, more transparent, and more comfortable for the readers to simply understand it and simply go through the story. So I believe that drawing a maps is exactly the way how to tell good stories with good endings, and maybe stories which will then deserve for new nice sequels. So we will do something similar. We will simply try to draw a map of our data landscape, of all the data that we have in the company. And of course, in history, all the maps were drawn on a paper. Today, we have the comfort of having digital maps. And I am not ashamed to say that I really like Google Maps because it can be used in various ways. For example, I can use it if I want to avoid a traffic jam if I go to the office. I want to use it when I go to mountains for hikings. I can use it if I want to know where I'm supposed to park my car, where there are parking zones, and so on. So all these digital maps have different layers. Yeah, they are multidimensional, and I can choose which layer or which dimension I want to see. And maybe I can even combine different layers. I can maybe combine, hiking trails with maybe weather forecast or something like that. So I can combine, different layers and see something new, something important about the landscape. And in our case, if this is not a terrain, an outdoor landscape, and if this is the landscape of the data in our company, this is exactly the same. So I believe that the way how to achieve a data transparency, how to visualize, everything about our data in our companies, is to do what I call data landscape mapping. Simply go to the terrain, scan everything, and then collect metadata in this case, because data about data is called metadata. So collect it, put it into one place, and then visualize it. That's it. That's all. And if I mention the metadata, the data underneath of our digital maps, metadata, it needs to have a structure. I already said that it's multidimensional, layered, But there is important feature. Whenever you start mapping whatever, you need to agree on the lowest, most detailed granularity of the subject. And in our case, I say that we should define a data element as the lowest granularity, the maximum level of detail. What it is data element? If we talk about structured data, the easiest way how to imagine data element is a column in a database table. So it contains some data, it has some structure, it belongs to a table, it has lots of relations, relationships, and so on. You may say that not always the data is organized in database tables or flat files. It can be organized in different structures, for example, hierarchical structures, which we can see in XML files. So data element can be also understood as a tag in XML file or an item in JSON structure and so on. So it's structured. And you also may admit that there are also data present in unstructured ways, like for example, images or PDF files and so on. I agree that for the purpose of the mapping, we would need to somehow transform unstructured data into more structured form to try to find what are the data elements. There are ways how to do it, but I do not want to spend much time about this. Let's simplify our lives for now, and let's say that we will focus only on data which is structured. And there is a plenty of such data in our companies, and I would say most of them that we need to manage. So data element, but simply saying, is a column in each table of each database in each system. Second feature of the metadata structure is its dimensionality. You know, dimensions, we can also use the analogy with digital maps. These are the layers of the map, different ways of looking at the subject, in our case, at the data. And there are 4 important dimensions. And at the beginning of this, or invitation for this webinar, we promised to talk about 4 steps towards data transparency. And these 4 steps are equal to 4 most important dimensions of our data transparency model. There are some more, maybe derived dimensions. I will talk about them later, but now we will focus on these 4 most important ones. But before we do that, I will give you 3 more recommendations. So first recommendation is, if you are at the beginning and maybe you are that newly nominated data governance officer in your company, you may be replaced someone else, or you were hired directly into this position, and you need to do some initial steps, and you do not have much time because you need to start understanding the data and drawing some maybe roadmap towards the treasure, and you need to start quickly understanding. So first, do not spend a lot of money for specific and costly tools. Don't be ashamed for using Excel. We may do a lot of things with Excel. It can contain a lot of data. It is flexible. It gives us the way how to structure what we collected. So Excel is the right tool for the first step, and don't be ashamed for using it. Maybe you will also start using some small relational database where you will collect some more data. That's also possible, but Excel should be enough for the initial steps. Second, combine manual and automated and semi-automated activities. Of course, you can do a lot of automatic activities like scanning. There is again analogy with cartography. So you can scan the data from satellites. You can scan the Earth surface, and you can use it when you collect data for your maps. Very similarly, we can use a lot of automated tools for data profiling, for data lineage detection, for semantic detection, and so on. We can use them. I would suggest we use them very wisely. We decide what exactly we want to scan and what we will do with the results of the scanning. And I believe that we will need also to do a lot of manual steps. We will, again, as those land surveyors or explorers of unknown islands. We will need to go to the terrain. We will need to go to the company, and we will need to ask different people. We will need to go into documentation, maybe into archives, and try to get most of the available information and data about our data landscape. So we will combine manual, automated, and we will combine it in a semi-automated way. So sometimes maybe we will need to scan something again and again with different configuration, and we will need to collect or clean up the collected metadata and so on. The third recommendation is, if you remember those ancient maps, there also were places which were simply empty or blank, because those people, those explorers who came into the country, they were for some reasons discouraged from going somewhere because they believe that there are some wild, dangerous animals. So they simply put a blank spot on the map, and they wrote hic sunt leones. There are lions. We do not know what is there. Simply, it's a white space on our map. I think we should allow for something similar when we do the mapping. We do not need to collect complete information. The metadata matrix does not necessarily to be 100% dense. Yeah, so there can be white spaces, or maybe some spaces can be only high level. So we do not need to go to the lowest granularity of data elements. Sometimes we will stop at the level of applications, systems, databases, and so on. So these were the three recommendations before we start. And now, what are the 4 dimensions? First dimension, logical data model. Now, I'm not talking about modeling of those era diagrams in a Power Designer or Enterprise Architect. I'm rather talking about conceptual logical data model, which is derived from a business model of a company. For example, in banking or in financial services, there is a domain industry standard data model and business model for the whole industry. And all the users are used to work with entities like counterparties or contracts and so on. And they understand these generic entities. They understand what it means that, for example, under counterparties, we can find customers, bankers, investors, whatever, regulators, and so on. And under contracts, we can find credit cards, bank accounts, investment products, mortgages, and so on. And there are a lot of relationships among those entities. And the good thing is that people from business, from the pure business point of view, they understand what these entities are. They can define them. They can attribute some properties and so on. And from technical perspective, there are also people who can imagine really technical pieces of data which can be linked to these logical entities. It's very important because it gives names to our data. It defines what data we are going to take care of, what data is really interesting for us, what will be in the map. And there may be also white spaces, few entities of data, which we will simply decide not to map, or at least not at the beginning. Second important step is a physical aspect of the data, physical data store. So where is the data physically? So if I know that I need to take care of data about customers, I am asking myself, where shall I find it? In which systems? In CRM system? What other systems? Where physically? Are there any overlaps? For example, are there systems which contain only data about specific segments of my business? Or are there systems which contain all the data about all my customers? What is the quality? In which system should I find a better data, more complete data, and so on? If there are more systems, I will also ask myself, shall I somehow need to consolidate the data? Shall I need to create golden records, to pick up the most, the best quality pieces of the data and use it for a golden records creation? And also I will ask what such physical things like, what are the volumes of the data? How many records? How much of the data is there in total? How much new data am I receiving every day? What is the proportion of data in specific system which changes through the day? Is it a frozen old database which is only in the read-only mode and nothing changes inside? Or is it a highly dynamical transactional system which maybe changes 1/3 of the whole database every day? These are very important things. And when we come to a new company and start talking about some data management program or whatever, very often such information is not available right away, and it's very easily to collect it, because you can measure, you can ask your database administrators about the volumes, numbers of records, and these things. So it's very important, and it gives us lots of answers when we start thinking more about data. So this was the second dimension. Third dimension, very important and less easy, I would say, to collect, is the context of business processes. So how frequently do we need specific set of data, but not in general, but in context of a specific business process? What are these business processes? For example, customer servicing is one example of the process. Accounting closure at the end of the year is a different process. So we should have a list of these important processes for which our data are used to be used, or serve the data for which processes. And of course, there will be different requirements from different processes. Customer servicing requires high availability of the data. The data needs to be fresh. I need to know, the last event which happened in relation to a specific customer. Very likely, I will need high quality and big level of detail of this data. And or for campaign management, there can be different examples of different process. Maybe for campaign management, I will not need the whole set of data. Maybe I will just pick up the part of most suitable data for a specific campaign, and maybe I will pick up only that part, those records which have the best quality, for example, of contacts. Only those customers that I'm 100% sure that I know their email address, I will pick up. And there can be another process, like, for example, accounting closure, which happens only once a year. I do not need to touch the data the whole year. Maybe only I need to gradually keep collecting such data. And only once a year I will collect it. I will check it against maybe general ledger, and I will do some activity. So different processes may touch the same data, but in a different way, in different time, with different frequency, and with different maybe data quality requirements. So it's very important to put this dimension into our map, because it tells very important things and tells us what we need to do with the data in specific contexts. So this was the third dimension, and the fourth dimension is organization dimension. Who owns the data? And there are three roles which we need to mention. The first role is the formal ownership of the data. I think there is a good example of data privacy. We all went through these GDPR projects a couple of years ago, and one of the important aspects of managing privacy is taking responsibility for specific pieces of data. So, for example, for customers' data, somebody needs to be formally responsible and either take some actions in advance, or at least if there is an incident or breach, then such a person needs to decide what we shall do, how shall we, resolve it, and so on. So the formal ownership is very important, and I guess that this will be very important, very, very difficult to find, formal owners of specific pieces of data. Second, who understands the data? Who are the data experts? Those are maybe, or data stewards. I don't want to go to details, what are differences among these roles, but who understand it? Who can tell me anything about the data? How good quality is the data? What is the history? How far can I go, in history to be sure that I will still get, high quality data of specific entity? This person would also know where the data is, who uses such data, how frequently, and so on and so on. And then the third role is who takes care of the data. So who is technically responsible for doing backups, restorations, who really cleans up the data, resolves data quality incidents, and so on. So these are three different roles. Very often these will be represented by different groups of people, but we should know who these people are. And I think that if I mention the white spaces in our map, I think that we will see a lot of white spaces in this mapping dimension or layer, because simply there will be a lot of pieces of data which will have no owners, which maybe nobody will understand in sufficient detail. And theoretically, it may happen that there will be also pieces of data who are taken care of by nobody in the company. Some archives, frozen databases, and so on. But it's important to try to map it, to prepare metadata in these 4 dimensions. And I ordered these dimensions 1, 2, 3, 4, but I'm not saying that we need to go strictly sequentially. Yes, we should start with logical, then go to physical, then ask business, and then try to find owners. But I think that we will need to do a lot of iterations. Go back to physical data repositories, maybe redefine the data model, and so on. And the metadata model, which consists only of 4 dimensions, can be useful, at least at the beginning, because you will get important answers. How much data do I have, in which systems, who are the most important counterparts from business, from IT, and so on. But I think that it will not be enough. We'll need to talk about more dimensions. Some of these dimensions I've already mentioned, like data quality, for example, or data profiling, which means measuring the contents of the data, how many records, how many distinct values, how many null values in specific columns can I see, and so on. Then there is another dimension, which is data semantics. We can even automatically define the semantics. You may say that semantics is something similar to a logical model, to naming of the data. But I can give you good examples where the data which belong to a specific piece of logical data model contain different semantics. So we need to try to understand really what is inside of the data. We may find that, for example, in a column which should contain only mobile phones of our customers, we will find, for example, also email addresses or even physical addresses and so on. And we should understand it. Other dimensions, data utilization. I already mentioned that different data might be utilized differently by different processes. So sometimes I will touch the data every day with high latency. Sometimes I will touch it only once a month, once a year. But also there might be different requirements, not how available such data is, but how often it gets refreshed or collected. So the data utilization is very important aspect of the model, important layer. And I think one of the last, which I didn't mention, is data lineage. Data lineage, technically speaking, tells us which pieces of data depend on data sources and so on. It can tell us, what, pardon. If I have a report, for example, and there are some numbers in the report, I should technically be able to trace what were the sources of each number, how did I collect it, what computations did I make, and so on. There are good tools which can do this, technically. They provide this technical map of data dependencies. But if you see the data lineage map itself, without any other information, it would not tell you much. Definitely not if you come from the business and they tell you lots of names of database columns and a lot of arrows among them. You will not get the information. You need to link this layer of metadata with some other layer, maybe with the logical model and so on. And last dimension, which we can see on this example of our metadata model, is last but not least, maybe least popular one, and it's information security and privacy. If you want to make sure that, for example, you know where your customers' sensitive data can be found, you need to do this exercise of data mapping. You need to categorize your data. You need to understand the real semantics of the data. So I would say that this dimension of information security is quite ultimate in relation to the other dimensions, because you need to really collect data for other dimensions to be able to comply with all the information security and privacy management requirements. So I think that these dimensions are really those that you will need to put into your map. And let's say that you collected all this information and you followed my recommendation to first keep it in Excel or in a small relational database. And you may ask, okay, now what? We spend a lot of time, few weeks collecting metadata, asking people, scanning data, and so on. What do we have? We have different pieces, non-homogeneous, metadata. My suggestion is already when you start collecting metadata, start thinking of a generic metadata model that you will then build, and you will transform your collected metadata into this metadata model. And I'm presenting very simple, reduced, very generic metadata model, which contains just 3 entities. Data element as one entity, already explained. Data object is any collection of data elements. So if data element is a column in a table, then table is a data object. But we can go further. We can see that there are database schemas, there are databases, there are applications and systems which are more high-level collections of our data elements. So schematically on this picture you see those arrows as loops which define the relationships between the hierarchical time relationships among these entities. So various levels of data objects can be hierarchically organized into high-level objects and so on. And the third entity in the model is attribute, which means any property, anything that we want to collect about our data. It can be number of records in a table, it can be the detected semantics, whatever information in any dimension. It is generally called attribute. It can be linked to data element, or it can be linked to higher level of data object. And of course, there can be again hierarchical structures and relationships among those attributes. For example, if I want to show some let's say histogram of the values in a database column, I will organize it in a set of attributes, and I will give them some hierarchical structure. I said three entities, but we have 6 boxes on the picture. Those 3 other boxes represent instances of these, of objects, elements, and attributes. It means if we continue with the mapping process in time, we will come back to the terrain, we will rescan something, so we will get new instance of metadata. For example, if we scan semantics of our data every week or every month, we will get different versions of metadata, and we should be able to organize them. So we give them names of instances, and we store them as instances of the scanning or manual mapping, whatever. So this was a generic metadata model, and it is important, to see that even though we define the lowest granularity of data element, we allow for higher levels of granularity. It is important because you will always get different levels of detail from your different scannings in different layers or dimensions of the map, and you should be able always to link them on at least specific, ideally the lowest, more detailed level of granularity, but not always it will be available. So you will need to find the lowest possible mutual level of granularity among different layers, so that you can combine it and show in a report or visualize it. And there is an example. Once you collected metadata organized in a ideally generic metadata structure, you are ready to present it. You start exploring, your data landscape by visualizing. At the beginning, and especially if you start using only Excel, you will not get nice images like taken from satellites. If you talk about the digital maps like Google, but you will be able to organize all those all those metadata in nice heat maps. You know, I really like heat maps because it can combine information from different layers. In this case, for example, it's very simplified case. One dimension is data retention capacity attributed to hypothetical systems in years. So system A contains 1 year of data, system B, maybe data warehouse, contains 15 years of data. And then there are business processes, 1 to 5, with different requirements. So I can very easily, if I collect metadata like this on the level of systems and processes, I can combine it and put it into a heat map. And I will see, for example, that hypothetically, and again, it's very simplified, example, but it tells me that system B would suffice for all the business processes theoretically, while system D and system D would not suffice for almost any of those processes because it contains only 6 months of data. Again, very simplified version, but I just wanted to explain, how we recommend to visualize metadata on a specific level of detail. So heat maps is one of the most useful ways how to visualize the metadata about the data landscape. And finally, the last slide of this presentation tells us about the next steps, how to go forward. Of course, you will not suffice with Excel forever. You will need to have something more sophisticated. But again, I don't believe in those robust, expensive tools which offer lots of features, but you need to have a specific people, experts who know how to work with that system. And again, they will very often start building something from scratch because your needs will be specific. Our approach is very similar to business data warehousing. Data warehouse is something where you collect and integrate data about your business. You structure the data in some data model, and then you produce data marts, offer data to business users, and produce lots of reports and so on. The concept of integrated metadata solution is a metadata warehouse. Very pure analogy to business data warehouse, with the only difference that the subject of metadata warehouse is not business data, but it is metadata. So you collect metadata, as we explained, various ways, automatically, manually, and so on, one-time collection of metadata or regular collection, whatever, and you organize it, you transform it into a metadata model, one place, you integrate metadata, maybe you clean it, you get it to the same level of detail, of comparability, and then you offer this metadata for consumption for analysts, architects, whoever may need the data, and of course you can visualize it with using some regular presentation tools that you normally use in your business intelligence or business data warehouse. So this is our recommendation. You will again need to build something like metadata warehouse on your own. You cannot buy it. You cannot purchase metadata integrated solution somewhere on the market. You need to build it inside of your company using your experts, your expertise, understanding your needs, and maybe you can outsource some experts who know how to do this, who can help you with the whole process, but you cannot buy the solution. Well, that's it from my side, what I wanted to share with you regarding the way how to better and quickly understand the data landscape in your company. And I would like to give you a chance to ask questions, if there are any. No questions, or? Yes, I see in the chat. I can read a question that I mentioned a analogy with business data warehouse. Yes, on the previous slide. And the question is whether instead of metadata warehousing, we can imagine something like more operational, something like operational metadata store or ODS. Yes, I think it's a good idea. It was just an analogy, and I think that while business data warehouse is something more static and ODS or operational data store is something that we use for maybe even online integration. I can imagine something very similar. So it can be that you use concepts or principles of operational data storage for metadata. It can be whatever operational types of metadata that you collect from your monitoring processes, from incident and problem management in IT, and you combine it with other pieces. So yes, definitely, it's a good idea not to build only metadata warehouses as those robust, static, rather static solutions, and to make it more operational. Definitely, yes. Okay. Maybe some other questions. Okay, there are no more questions. Then thank you very much for your time, for your attention. And I would like to ask you also to spend a few more minutes with our questionnaire, which will be sent to you via email after we finish with the whole webinar. And thank you very much, and see you. Goodbye.